Okay, so for my base function, I've chosen the y equals x to the power of 3. And the way that that would look on a graph is like so. And we're going to be making a few transformations to this function. The first one that we're going to be doing is y equals x to the power of 3 plus 2. And this is going to cause a vertical translation up 2 units. So after we draw it out, here's what's going to look like. So you can see it has moved up 2 units, just like so. The next transformation that we're going to be doing is in the brackets, we're going to be doing, so it would be y equals, in brackets, x plus 2 to the power of 3 plus 2, which is what we already had originally. And this is going to cause a horizontal translation left 2 units. So I'll just draw that out. You can see here, it's gone left 2 units, and that is roughly what it will look like. Next, we're going to be putting a 3 in front of the bracket, and this is going to cause a vertical stretch by a factor of 3. So our new function would look like y equals 3 bracket x plus 2 bracket to the power of 3 plus 2. Like I said, this is going to cause a vertical stretch by a factor of 3. This is how it's going to look. So it stays on the same axis point. It's just almost a way to describe it would be it looks a little bit skinnier because it's being stretched. Next, we are going to do y equals -1 bracket 3 bracket x plus 2 double bracket to the power of 3 plus 2. So this -1 is going to allow us to reflect it in the y-axis. So this is what it will look like. So once again, it stays on the same axis point, except it is being flipped this way along the y-axis. And lastly, we are going to horizontally compress our function by a factor of 3. And the way we do that is within the double brackets with the x plus 2, we put a 3 before the x. So our final function will look like y equals -1 open bracket 3 open bracket 3x plus 2 double close bracket to the power of 3 plus 2. So now I'm going to draw that out. And it is really hard to tell because it has been horizontally compressed by a factor of 3 so much that it is very skinny, but you can see there's our line there, and it would come down right around here. And that's how you apply all the transformations to a function.